Welcome to Amber Skies, it's Blaze here. Yeah, we've got episode, what, 4 is it? Oh gosh, how time flies. And storing 3D data I'm reading on my notes here. Nice coffee. Let's have a look. We've got our object data structure. I think I did an update where I explained that I've just collapsed these to make it tidier, like that. And I've also altered the name here on OBJ data, and I found me a pointy thing because I noticed that my mouse pointer kept disappearing on the last few videos, so I've got a pointy thing in case I want to point something out. Let's get on with it then. What we're going to do, we want to store some data. What's a good way of doing that? Create a file, I suppose. So development. We'll keep with development for now, and we shall add a new item. Oh, this is Microsoft, isn't it? Okay, do one item at a time then. So C++ file, and I'll do the header first. Always do the header first. And the header is going to be called, I don't know, how's about store obj. Why not? Something like that. .h. Yeah, that'll do, won't it? Yeah, of course it will. We'll add that. And it just comes up with the usual pragma wants kind of thing. A few of them. And we also need a CPP file. Hey, we're actually going to do a first CPP file. Oh my god. Yeah, and I just called it what? Source. Great one. Come here. Okay, rename you from here. What? No. Source. Rename. Got it this time, and it's just, I don't believe this. It's going to be another one of those days, and it should be in lowercase as well, so it should be store. And then obj. And it'll be a .cpp, yep. And I'll just get that to a lowercase s, please. There we go. Cannot rename it because you're an idiot. Alright, delete it then. Yeah, just delete it, I don't care. We'll make another. Grief. This is such a fun system to use. Yes, I remember. If you try and rename things in this, it just goes to absolute rubbish. Yeah, well, never mind. It can't handle renamings. Alright. So, S-T-O-R-E, S-T-O-R-E, yay. Let's just include ourselves, and we are going to be today store obj. Nice. We'll give ourselves a namespace of model, I think we're using for this one. I hope so, because that's what I just put. Right, okay. Let's just copy that over into this one. Hold out. Alright, what we're going to do, we're going to have a class, aren't we? Yeah, but we are going to need a few things, aren't we? Includes. Let's do some includes first. Hash include. It's using Qt, so it's QString. We're going to need that, definitely. We're also going to need a vector of some kind, so include. Let's have the Q vector. Oh, which one's it giving me? Wish I could move in and out of these. I'll have the other Q string, please. Is there a difference? Not really, but it just reminds me that it's the QT thingy when it hasn't got dot H's on the end, and it's C++. Hooray! We'll also have to include our structs. So let's do that as well, and they are in obj data structure.h, because I renamed it successfully without too much argument from our Visual Studio. I still don't understand that, but never mind. So let's start this up. Store obj. We'll make it a class, shall we? Yeah, why not? We'll have a class, store obj. Yep, okay. Ding, 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 ding. We will need a Q vector, so let's have one of those. It's a Q vector. How do we do Q vec? Tors. Yeah, it'll be one of those doofries, won't it? One of them. An angle bracket. We'll do the first. What's our first one? Vertex. We'll have a vertex. How about that? This is our example one anyway. So vertex. And it's a star at the end because I don't want it hanging around in our CPU's memory. I want it out in the machine's memory because there could be a lot of data there. There could be an awful lot of data there. So I don't want it cluttering us up. I'm going to call this M underscore. I'll call it vertex data because we can. Yeah, I'll do. So the name of the vector is held in local memory, where the actual data in the vertex of the list of vertices will be held in the outer memory of the machine rather than the CPU memory. I don't know what to call it, main memory or whatever, I suppose. Could do. Never really quite thought about that before, but anyway. Let's have a public. Here we go. Public we go. Oh, I've got that system going, have I? Okay, let's store obj. That'll do. I'll also title that one. I want a destructor for this because we have a star. Anytime you see a star, you know you're going to have to do a deletion somehow. So it's store obj again. There we go. We'll have those two. So let's add them first of all. Go to definition, blah, 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 blah. Do I just not point? Can I just do that and click? Create definition of blah, blah. That works, doesn't it? Yes, it does. Okay, that's lovely. So it's colon and then nothing. You can't. It's a doobry. It's not a... It's inside the angle brackets. You can't do it. So that's going to be empty. Yeah, a lot of variables I know. Right, just pop that there. That'll do. Save that out. And close it. And the next one, we'll pop you in. Yeah, this will be slightly different. I'll put you as empty for now. You might get a bit awkward, I don't know. In fact, I'm going to put them all to empty. I'm just going to try and set them up for now. And then we'll go and have a look at them properly. What else will we need? Except for a cat meowing in the background. Not a lot. 3 or 4 more, I think. So let's have a... I'm just going to put everything as void until I know different. I want an initialize. and that's going to be store obj. There we go. What else can I have? Let's have a look. Whilst I'm thinking about it, let's pop it in. And if you're wondering why I always put empty in, it's in case I forget to do anything. It then looks as though I thought about it. At least I thought about it. What else are we going to need? Oh, we're going to need to store the data, aren't we? So store data. That will need a string. So that's going to be a Q string. And that will be a text, a line of text. And line. That'll do. Yeah. That'll make sense, I hope. If it doesn't, we'll change it. That's the way I work, as you might have found out. Yeah, we'll have that one. Let's pop you in. And that is empty for now. Save and disappear. If it's an easy one, I'll just write it in, but I don't think anything's easy in this one. Void, yes. We will need a cleanup. We're using a vector of pointers. We will definitely need a cleanup. So we'll have clean storage. AGE, please, not F. There we go. Looking good. Private. Will I want anything in private? Yes, the actual method that does the actual storing. So this will be store vertex data. Yes, we've got store data, and then we can actually make it more precise, their data. Yeah, that'll do. And that will still be, believe it or not, a Q string. Don't need to put it in now, we're in the same file, so that'll be fine. Yeah, I'm happy with that. Let's get this clean storage up. There we go. I'll pop you in. Gosh, it's nice not to be doing structures. Yes, but I'm blooming glad we've got them all now, because look at what we've got now, because we haven't got all of those structures. But there is a problem. Well, not a problem, but a bit of work to do. Depending on how you want to do it, really. This is where we find out what we want and what we don't want. Now, there's many, many ways of doing this. And I mean many, many ways. So bear with me. Let's have a look at a few ways of doing it, I think. So are we alright with all of that there? Yeah, I can get rid of you. What about main? Yeah, we're doing storage. I've got all the stuff here in the main, so I'll keep you open. I've got all my notes. So this is what we've got. Now, when it comes to storage, as you can see, I've got two. I've broken it into two parts. I've got store data, and then I've got specifically store vertex data. Now, that infers that we are going to have to do a store texture coordinate, and then another function, store vertex normals, and then another function, store vertex parameter, etc., etc., etc. Now, is there a way around that? Well, yeah, Of course there is, it's C++, we can write our own language. What we could do is say, instead, store 4 floats, store 3 floats, store 3 floats, store 3 floats. You get me drift? Yeah, store that lot. Store int, store qstring, store qstring, 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 qstring. In other words, make it more generic. Oh, 3 floats, 3 floats, 3 floats, 3 floats, 1 float, 1 int, qstring, qstring. So you can get the idea. We can either go for storing the name, or we can make a function to store a type. Let's do both. So for our first test, I'm going to do store vertex, which is 4 floats. I'm not going to do a store 4 floats because there is only 1. All the rest are 3 floats. And you hadn't noticed, had you? That's interesting. So we don't actually do a second storage of 4 floats anywhere. We don't do any of the alphas. I wonder why. I'm sure it's supposed to be included, the alpha. But I think it's actually included. Is it in here? I'm sure I saw transparency somewhere. Oh dear. Blades' brains have gone to sleep. Let's have some coffee and look. This is mostly doing textures. There's your blending. That's a type of transparency, but a transparency on top of each other. And that creates a blend of 2 things. Stencil displacement. Bump. Alpha texture. Yeah, that's transparency. Like for doing windows and things. Illumination. Transparent, yeah. It's just a float by itself. So that's your alpha value there. Oh well. Hey ho. Yeah, it is. Comes after the colours. So yeah. I'll keep this one as it is, and we'll see how in depth it is. And then the next one we'll do after vertex, we will do store 3 floats. Yeah, I think we're going to do it. It's going to save a lot of work if we do it that way, rather than being idiotic about all of this. Because we're still going to have a ton of vectors. 1 vector per struct. Yeah. I can't get around that unless I start merging structs together, which we could do. For instance, on colour, you could just have 1 structure for colour. That's there on the faces. That's, yeah, colours down here. But I've got to be careful because colour might not be included. So you would have material name, and you would make 1 struct out of all of these. But then, yeah, it actually makes it worse rather than easier, because then you've got 9 floats. Oh, and a transparency, and a specular, so 12 floats. Oh, go away. Go away, Blades, you're just confusing yourself. So what I'm going to do, I will go back to that file after all. Now I'm thinking about it. So in here, after vertex data, because that's the important one, every single file has to have vertex data. Full stop. You don't get a choice in the matter. And that's tough, isn't it? So, for instance, you could have store, what did I say, 3 floats. So 3 floats. Like that. And then you would have Q string line. There you go. They're all void at the moment. Probably not going to end up that way, but hey ho, we'll see how things go. And that function will then cover every single structure that has 3 floats in it, or is made up of 3 floats, which is quite a lot of them. So that saves a ton of problems, but it also gives us another problem. How do we get the type? And this is where things get a little bit strange. Because what you've got to do is then try and work out what type it is. I'm not sure I'd know how to do that straight off without researching it. It's not something I know off the top of my head. Because you see, this is already a type. Does it say it? No, it doesn't say it there, but it is. Q vector. Q vector is a type, isn't it? Int. Yeah, it's const t and value. Sorry, Q vector t is a type. So, yeah. That's going to be fun, me trying to work that out. Yeah, that's what I was looking at earlier, seeing whether we could do it or not. I'm not overly sure whether that would be a good idea, because this I'm not sure about. So what I'm going to do is I'm going to leave it as an idea. Just an idea for now. There we go. Yeah, I'll leave that. And we'll just concentrate on doing these and getting these working first of all, I think. So, how can we do this? First of all, let's have a look at the overall picture. Yes, I've been drawing on my whiteboard. Well, blackboard. Sorry, chalkboard. God, how pathetic. Sorry. I'm old. Right, okay, that's all right there. Where are we on here? Yeah, just checking my notes, and yeah, there's not much on it. Right, okay. Just getting my notes up. So this is what we've got so far. We've got structs, and we're just doing vector storage now. That's this one here. I could call it vector storage, but I think store obj, because it really is vector storage. Literally, we're storing in vectors. But I don't like that. It's a little bit too how can you put it? Computery, I think, vector storage. What I'm trying to think of is a warehouse. So we've got the structure of our data. We're then going to store our data. So it could be store data, this, rather than vector storage. We'll just call it store data. Can't. And that could then, it could actually. Yeah, we could. What do you think? Store data or store obj? No, because later on there might be different file types, and this would only refer to obj files. Store data would be too generic. Okay, we'll go with that. So what we're going to do is we're going to put our structs into this vector storage. So to do this, as you can, we do that by just one sec, just move you up slightly to there. We do that by placing our structs in vectors, and you just see me do that in here. This is how we put our structs into a vector. So that's our struct there. It says struct model : column vertex. It knows what it's doing. Honest. Does it really? Okay. So that's what we're going to do. We're going to place our structs into storage, and then we're going to read our file and put the data into our storage. Well, our vector storage. We're then going to send all of that through our application, whatever it is, API, application program interface. And that is going to be sent, the job of the API is to take our data and place it onto our graphics card. This is our graphics card, and at the same time as placing it onto our graphics card, it's going to receive information from our graphics card, placing that into what I'm going to call entity data. That's the bit we're after. That will tell us how to place the final model, or entity, as it's sometimes known in the trade. We call it entity, I don't know why. We like this entity thing. Buzzwords in computer science and programming. I don't know, entity. Well, it means a thing, an object. It just means a thing, actually, not even an object. So entity data here is what we will arrive at finally. Entity will hold the index, and it will hold the VAO identity. It will hold our texture identities if textures exist. It will hold any other information that we then deem fit to keep or create. But that's the main bits. The main bits are we need to know the ID of that VAO, which is just a list of buffers, because all of these are buffers, by the way. Each one of these vector storages, like the vertex vector, is just a buffer. It's just a block of memory with our data in. That's all it is. I'll prove it to you later. Don't worry, I'll show you how to use it properly. And yeah, I think we'll be all right with that. Right, chattery bit over with. Let's do the programming. Where are we up to? So, start at the top. Initialize. What do we need to initialize? Anything? Nah. Destruct anything? No, I'm not gonna put this in the destructor. I want to put it in clean storage. There's a big reason for it, because the destructor only happens when this class is destroyed, this object is destroyed. So I'm going to put it in clean storage instead. So we'll do that one first. And what this does is stop memory leaks. It cleans the storage out. It gets rid of all of our data. And how do we do that? It's usually quite easy. It's just for and int, I'll call it index, equals 0, whilst index is less than, and it's going to be, this is vertex data we're using at the moment, isn't it? Let's just check. Have I called it vertex data? I have, haven't I? I'm an idiot. It's a member, vertex data. No, I'm not an idiot. I did do it right. Underscore vertex data. That's better. Dot size. So, for each item of data in our vector, we are going to semicolon there, index together plus plus. For each item, we are just going to delete it. So it'll be delete, and it will be m_vertex data. And that'll just be I, won't it? Yeah, that'll do it. Is that legal? Well, not with I there, it isn't. Index. You see? Abbreviations. There we go. That makes more sense, doesn't it? So we've got we can index our vertex data, which means we can access each individual data member. And that's quite a nice way of doing it. I hope it works. Yes, it will. Yeah, it should work, because it's a pointer, isn't it? Yeah. I'm half happy with that one, because we are allowed to do a dot at the end. We don't have to do each one individually, do we? That'll delete the lot, won't it? Because there's no destroy on these. Okay. I'll keep it like that. I do believe wholeheartedly that that will take out the whole of the data. That will free up all the data, because it will wipe out the pointer, and that'll free the resources back up to the main memory of the computer, which is what we're looking for. So that's a good idea. Right, let's go up one. Let's go up to store data next. Let's see what we can do here. Now, this is rather easy, really. Yeah. So all we're going to do in here is put if, open brackets, and it's going to be a line, which we're given here. That's line. That's what we're passing into this function. And it's just a dot. And it starts with, I think I mentioned this in the last episode, that it was there, and I was really happy that it was there. And it starts with a V and a space. And we can check that, because that's what it says in here. So it's a V and a space, and then it's your, well, 1, 2, 3, 4 numbers in this case, or up to 4 numbers. Okay, so V space. We can't put V. Why can't we put V? Because this one here also starts with a V, as we can see from here, V. So if we try and ask it for a V, we're going to get them mixed up. So we need V space, and we'll check this one for VN. So we're going to be using 2 characters instead of just the first character. It'll do it for us, so it's not too much of a problem. It just, we need to be aware of why we're asking for a space. My throat's going, I don't believe this. Come here, coffee. So if the line starts with V and a space, it's a vertex. So what we're going to do is we are going to call it store vertex data, open brackets, line. There we go. And that's all we need to do, nothing more. Well, not for vertex data anyway. Lots more for the next ones, but hey-ho. So that's made that very simple, and that's why I was very happy about QString. This is why I love Qt. It's very, very easy to do things, and it reads properly. So now we've only got store vertex data to do. So we've got a way to check at what type of data the line has in it, which is by the first 2 characters. And then we've got a way to store that. This is where it could get a bit technical, because there's 4, not 3, so I'm going to need a 4th. And the 4th is optional, so we're going to need W. Now, I'm going to call it W because they do, not because I choose to. As you can see here, list of geometric vertices with X, Y, Z, W coordinates. W is optional and defaults to 1.0. We've already got it defaulting. So if we don't put it in, it'll go to 1.0 automatically, but we are going to put it in anyway. We don't really need that default, but I'm leaving it there in case we want to do our own vertices or make our own vertices up, say for a plane, a floor. I mean, you only need 4 vertices for that, so you don't load a model, you just write the 4 vertices out, don't you? You don't need to go to Blender to make a floor. Trust me on that one. It's easy to do yourself. So we'll have W. We know what W is. It's in the description, so we're happy. Any problems, just read the description from the wiki there. Then we need something called a Q string list. Now this little baby is fantastic. It's not something that you will probably know about straight off. It mentions it under our, what was it? Q file. Q file mentions it. So here, read a line, blah blah blah. No, it's not in here then. Oh, right, it's under Q string. Q string mentions it. Right, got it. Memory's coming back now. So Q string. Because what I was looking at was different ways on how to separate these. And I came up with, let's have a look, did I put it in main? Storing Q string, string store, yeah, list, pushback, yeah, okay. Yep. You see, I've already been looking at the faces. Split, is it? Line dot split? Is that what I'm trying to remember? Split behavior? No. Yes, you can control the behavior of Q string as well. So if we go down to S, here we go, Q split. Take the first one. Right, it splits a string into parts, and we can define how or by what character it splits. So we can split things on spaces or slashes or whatever we want. And what it does, they say auto parts. Well, I had to look it up because I didn't really know what this was on about. And then I looked through all of this. Does it say it somewhere? But it's actually a Q string list it goes into. There it is. It was on this one here. So Q string list is what it dumps the results into, and it does it for you. So you make a Q string and it'll dump it into a list. Yeah, it's quite an interesting one actually. I think it's a brilliant manipulation thingy, because it means we can do exactly what we want, which is ace. I love it. I love it all. So we've got a Q string list, and what we can do is we can take our line, no, we need a name for it, don't we? So data, we'll call it data. So Q string list data, equals, and it's going to be our line, and we're going to split it, and we want to split it by spaces, please. There we go. As simple as that. And that has created a list of data from zero, just like an array, just literally a list, 0, 1, 2, 3, 4, that kind of thing. So if we've got to check now, because remember we've got W and it's optional. If yeah, we've got to find out whether W exists. So line dot count spaces would be equal to 4. Then W will equal data at 4 dot to float, because it'll still be in string format, remember, so we need to convert it from string to float. So that's that. Else W will equal, and that will be the default value. So we're actually putting the default value in. 0f as a default value. So we've taken care of W. So if W exists, we assign it to our variable W. If it doesn't exist, then we assign it the value of 1, like it says in the text. And then all we've got to do is fill up our vertex data vector. So we do that by this lovely line, vertex data, and then it's dot push back, not front, and it's going to be a new item that we're making. It's a new, we're making it from the structure that we've defined. We've defined the structure of this. Now what we're going to do is put data into that structure and add it to the list called vertex data. Yeah, I know it's a lot of data manipulation, but it's worth it. It really is worth it. So its vertex is the structure, and we know how the vertex structure is made because we've got it here. So it's float x, float y, float z, float w. So what's x? X will be data at 1 to float. Oh, no, not like that. It won't work. So caps lock off. I've done it again, Anna. My typing is absolutely rubbish at times. And the next one, how many brackets have we got here? Crimes. Going mad on me brackets. Y will be the next one, so it's data at 2 to float. Yeah, that's right, isn't it? Yeah, that's right. And X, Y, Z is data at 3, believe it or not. Is this looking difficult yet to float? It's just stringing it all together. It looks more like Java than it does C++. And Qt actually supports Java style programming right out of the box. So that's possibly why. I think it might have been, parts of this might have been written by a Java expert. And of course the last bit is W. There we go, that's it. That's all we need to do. Now I want to check that this is working. Can't, because we haven't got the file. How long have we been on this? 48. 45 minutes, so yeah. So hopefully that's giving you an idea of what's coming up. We have a lot of if line starts with to do, and we have quite a few more of store 3 floats, store string to do. So I've only got a few more of these to do, and I also want to do that, don't I? Because I usually do. There we go. I think that's right. Yeah, that's right. So it's looking like we are going to be doing that. That's alright then, as long as it doesn't mix us up and make a mess of us. I'll work through it first and then make sure we're not messing up on there. So there we go. We have our first function. This, when completed, will be able to store everything from the obj file itself, and it will store everything in the same way, in a struct, written in the same way, and then it makes it very easy for us to write our API to put it into OpenGL once we know what OpenGL wants, that is. We'll work on that later, shall we? But for now, we're now storing them in memory in the structs. The structs are just a way of storing them. And what we're doing is we're combining the structs inside a list called a vector, which is Q vector. It says it better in here than I can say it. It really does. Here we go. Q vector class is a template class that produces a dynamic array, or in other words, a dynamic list. You don't have to define how big it is. Arrays, you have to define how big they are. Lists, you normally have to define how big they are. And you have to define them before you can compile the program, not during runtime. So vectors are the way around that. They're flexible. They're flexible arrays or flexible lists of items. Yeah, and we're just doing flexible lists of pointers in this case. So we're going to have a few of them, and we're going to have a few in the cleans, and we're going to have a few in the storages. Yes, it's going to be quite good fun. So before my voice gives out totally, what we'll do is we'll take a break. See you in the next video. You people take care out there, and by the way, have fun.